Dah. Okay.
Kira kan dekat. Jadi kan stok dia lah sampai habis air.
Okay, Assalamualaikum. Now I want to introduce my part, which is introduction. Okay, for this project, this hydrology project focus on collecting and analyzing localized field data for three key components of the hydrological cycle, which is rainfall, evaporation, and infiltration. Each group member construct at homemade rain gauge and record daily rainfall at 8 a.m. for 7 days. Evaporation was estimated using the Penman monograph method based on our location, and infiltration data was gathered using self-construct infiltration ring with repeated time water filling to determine soil infiltration rate and capacities, and Houghton infiltration model was applied to simulate future surface runoff. The project integrates fieldwork and engineering analysis to model real-life hydrological process across various residential environments.
So for calculation data, first thing is rainfall. We need to sum up all the cumulative water level that we get every daily data that we get, which is I get 0.6 and then we divide by 7 days to get 0.086 millimeter per day. We need a data in per day. So for evaporation data, first thing we need to find cloud cover and possible daylight D by using website, and then calculate N, which is possible daylight times by 1 minus cloud cover divided by 100, and then we get 12.32. Then this is the photo from the website. We need to find temperature, humidity, solar radiation, and wind speed also in the website sources. Then we use nomograph to find E1, E2, E3, and E4. Then average EO. Then we get E average, which is E total divided by 7 days. We get 2.63 millimeter per day for evaporation data. So this is the nomograph that we use. So thirdly is infiltration data. So this is the formula that we use. Then we need to total the infiltration capacity, which is I get 0.158 millimeters. And then for the surface runoff, we need to calculate all the average from rainfall, evaporation, and infiltration. Then we use the formula runoff equal to rainfall minus evaporation and infiltration, which is we got negative 2.597. It is because there is no rain in 1 week, in 7 days.
For the rainfall data, as for rainfall data, it is a 7-day observation was done at Taman University, at the apartment at Taman University. The observation was performed between 19th to 25th of May, and with the reading daily at 8 a.m. There was no rainfall registered for the entire week, and the level remained the same at 0 mm every day of the week. This consistent finding confirms that no precipitation occurred during the observation time. The extended dry climate condition over the period of the week also paralleled other environment factors such as no runoff on the surface, no increase in infiltration, and steady rates of evaporation. Okay, next, evaporation measurement between the 19th and to 25th of May, also on the same day and the same location, apartment Taman University, provide an impression of environmental limitation over water loss. In the table, you can see temperature, relative humidity, wind speed, potential daylight, RA, and nomogram are the parameters that were evaluated using relative materials such as internet and weather sound. The greatest temperature between 26.72 and 28.44 degrees Celsius occurred on the 24th of May and was the greatest EO of 4.3 mm. The daylight ratio between 0.7 and 3.09 during the week 2 indicate greater sunlight and clearer skies that were favorable to increase the evaporation. The match of dark cloud dropping to 61% from 73%. RH varied from 0.65 to 0.52 with the low humidity favoring higher evaporation. These tendencies establish wind and dry air condition to be significant evaporation. EO varied from 0.37 mm to 4.3 mm and average 0.4 mm per week. The initial cycle, the total water took 5,674 seconds to completely permeate to the ground. If the rates were determined, the approximately 0.009 mm per second. During the second trial, the infiltration was slower and took around 10,800 seconds, while the rate decreased to 0.005 mm per second. The third cycle was not different, the water infiltration taking 13,390 seconds and the infiltration rate slowing down to 0.004 mm per second. The fourth cycle and the final cycle registered was the longest with a time of 23,873 seconds, with the infiltration rate slowing down to as low as 0.002 mm per second. On all four cycles, the infiltration capacity was also 0 mm. The infiltration was slow and kept going with every succeeding cycle, which shows that soil was becoming more and more saturated during the test.
Assalamualaikum, my name is Nurafika Ashira binti Rosi, metric number 0230045. During the observation week, the weather was mostly dry with almost no rainfall, and only one location, which is Cairo, recorded a small amount of rain, which is 0.6 mm, showing that rainfall was very limited and scattered. Next is evaporation levels, vary at each site mainly due to difference in temperature, sunlight, wind, and humidity. The highest evaporation was at Cyprus site, which is 11.07 mm per day, while the lowest was at Cairo site, which is 2.63 mm per day. Next is infiltration rates, also show big difference. Cyprus location had very high infiltration, about 2 at 1.6 mm per day, which suggests the soil there is sandy or loamy and absorb water easily. On the other hand, Sudan site had very low infiltration, likely due to compact or clay-like soil that holds water on the surface. As a result of the high evaporation and infiltration, runoff values were negative at many locations. This means that water either evaporation or was absorbed into the ground, leaving very little or no water to run off the surface. Overall, this showed that the risk of flooding during this period was very low. Thank you.
So in conclusion that we get from all of this project, first thing is key finding, minor to moderate variation in hydrological data, influencing factor such as soil type, vegetation, intubation, humidity and sunlight. Then learning outcome, which is we enhance student skill in field measurement and data analysis, and increase awareness of local hydrological variability even in geographically similar areas, and overall impact, valuable education experience for understanding local water process relevant to sustain water resource and environmental management.